All right, welcome to AP Chemistry. We're looking at the Unit 2 progress check. And this is just so you can check your work, make sure that you're on the right track in preparation for your test. So we're looking at this first part, and we're asking questions about N2 and N2H4. In the box below, we're supposed to draw the Lewis dot structure for N2. We always remember that when we are doing these things that we should do an electron count. So we know we have nitrogen. We know that there's two of those. We know nitrogen has 5 valence electrons. So our picture should have 10 electrons in that. So we show nitrogen, single bonded to nitrogen. We add our electrons 2, 4, 6, 8, 10. And then we notice, oops, we're short on getting our octet for oxygen. For nitrogen. And so we see that we need to add 4 more electrons. If we need to add 4 more electrons, that means we need to have 2 there and 2 there. Is for every 2 that we're short, we add another covalent bond. And the only place that we can add it is in between the nitrogen atoms. But also, when we add those, we have to remove 4 from the other atom. And now when we look at our count, we're going to see that we have 2, 4, 6, 8, 10, and our picture is good. And so that is how we draw the electron dot diagram for N2. And then it says in part B, based on the Lewis electron dot diagram you drew, is the N2 molecule polar or nonpolar? This is a very easy question. This would be nonpolar. And the reason why this is nonpolar is we're not looking at the electron geometry here. One, you're going to notice that it has one, there is no central atom. That's one thing. But then also, and so when there is no central atom, then all we have to look at is the bond polarity. And because nitrogen has the same electronegativity as nitrogen, the electrons shared between those two nitrogens are going to be equally shared. And so we can say nonpolar because electrons are shared equally between nitrogen atoms. And then you can say, and that would be fine. That's actually a great answer right there. It's actually a great answer. You could mention something about there being no difference in electronegativity. There is no difference in En between nitrogen atoms. All right, but probably that first statement is the best. Electrons are shared equally between nitrogen atoms. Why is that? Because there is zero difference in the electronegativity between nitrogen atoms. All right, hopefully get rid of that. Okay, so all right, so the next part, I don't know how to get rid of this little screen there. There we go. The next part, we look on the graph, indicate the distance that corresponds to the bond length of N2 molecule by placing an X on the horizontal axis. Boy, they're telling you exactly where to read this. And so this is the graph of N2. All we have to do is put an X as to where we read the bond length. We told you we read at the bottom here, we go to the x-axis. That is where we would find our internuclear distance. What an easy question. All right, and then on the graph, which shows the potential energy of N2 or in N atoms, carefully sketch a curve that corresponds to the potential energy of 2 oxygen atoms versus the distance between their nuclei. So we just have to show 2 oxygen atoms, and 2 oxygen atoms would be O2, and we actually have to draw the Lewis dot structure in order to determine this. And so now they're not telling you, they're not looking for that on here, but you have to know the dot structure for O2. So I'm just going to draw it up here. O2 we see has there's 2 oxygen and 6 valence electrons for a total of 12 electrons. So oxygen, just to speed up the process here, has a double bond. Remember that nitrogen in our picture has a what? Triple bond. And so now we are looking at the bond length between oxygen and nitrogen, and we should easily determine that this is longer. Why? Because double bonds are longer, and then they're also weaker than triple bonds. So we have to show a curve that is going to be have a longer bond length, and then we also know these are negative values here. Let's say this is negative 1,000. I don't know what it is, but negative 1,000 kilojoules per mole. We know that oxygen's value is going to be a numerical value that is a more positive or a less negative value. So we could say this is, I don't know, negative 750. All right. And so I don't think it's quite halfway there to zero, but so 750. So now we can just simply draw a longer bond length and a curve that is a little bit higher than what we see in nitrogen. Why? Because oxygen has a double bond versus nitrogen having a triple bond. All right, it's the difference in the bond order. We know that triple bonds are stronger and they have a shorter bond length. So our curve has to show that. So your curve should always take the shape of the one that we have drawn here. It should always have a very similar shape to that. So this does not mean you have to know exact values or anything like that, because we do not. All we have to do is draw a potential curve that would match what we see relative to nitrogen. All right, and so my curve here would be perfect. Why is that perfect? Well, because my bond length is, let's see if we get a different color here, right here, right? And we see it's over to the right, so it has a higher bond length. And then also, if we look at the potential energy, I didn't draw it exactly where I said I was going to draw it, but it does not matter because it's the bottom of the curve is above the bottom of the curve of the one drawn for nitrogen, indicating that it has less bond enthalpy. And so um, that's how we draw that graph. And so that's all we have to do there. So let's see. The next part, we go to E. It says a sample of N2H4 has a mass of 25 grams. Identify the numerical quantity that's needed to convert the number of grams of N2H4 to the number of moles. Okay, so, and we do not need to do the calculation. So if we took our given 25 grams of N2H4, then what we would need to do is we would need to find a mass of N2H4 that equals 1 mole of N2H4. Does anyone know what we call the mass of 1 mole of N2H4? That's right. We call that the molar mass. So we'd have to look up the molar mass, or you'd have to calculate the molar mass of N2H4, and then you would just simply say the molar mass. All right. And so we can do that real quick. We say nitrogen, there's 2 times 14.01. So that's 28.02. And we have hydrogen, which is 4 times 1.008, which is 4.032. Add those things up, and you're approximately at 32.05. I think that's right, 32.05 grams per mole. All right. And so we could simply then say the molar mass is the answer. And it would be 32.05 grams per mole N2H4. All right, something like that. All right, and so And maybe my addition is off, but I don't think it is. All right, so we'll move on to the next one. We got the Lewis dot diagram of N2H4 is shown. Based on the Lewis electron dot diagrams of N2 and N2H4, compare the length of the nitrogen to nitrogen bond in N2 with the length of the nitrogen to nitrogen bond in N2H4. Okay, this is actually really, really easy. We see here the nitrogen bond in N2H4 is a single bond. We saw in N2 that it was a triple bond. So what do we know about the length? The length of, make sure I answer this right. Compare the length of the nitrogen to nitrogen bond in N2 with the length of the nitrogen in. Okay, so all we have to do is say the length of the N2 bond is shorter. We don't even have to say why, because it doesn't say explain, but we can do it because it is a triple bond, whereas the bond between nitrogen atoms in N2H4 is a single bond. All right, that would be a perfect answer. But really, stick to answering the question. The length of the N2 bond is shorter. If they say explain, then you have to explain. They didn't say to explain. Don't give too much information. Just say the length of the N2 bond is shorter. All right, and then we look at, based on the electron dot diagram of N2 and N2H4, compare the strength of the nitrogen to nitrogen bond. Again, we can say the strength of the nitrogen, and you can write it exactly how they have it. Nitrogen to nitrogen bond in N2 is stronger. And that would answer the question. Why is it? Because it's a triple bond. Triple bonds have are stronger and shorter than what we see in single bonds. All right, and then identify the hybridization of N atoms in N2H4. Okay, now we have to go to our Lewis structure. So we're looking at the nitrogen atoms in particular. We look at those, we see, let's just look at one of them, they're both the same. But we have 1, 2, 3 electron groups around nitrogen, 1, 2, 3 bonding electron groups around nitrogen, and then 1 lone pair. So we have four, what do you want to say? 4 electron groups. We're not asked to tell about the electron and molecular geometry. It just asks us to tell about the hybridization. But you should know 4 electron groups, that is going to be tetrahedral. When we have 4 electron groups and then 3 of those are bonding and 1 is non-bonding, that's trigonal pyramidal. So, and then we should also know the bond angle is somewhere slightly less than 109.5. So we might say the bond angle is approximately 108 degrees. But they didn't ask any of that. They ask what is the hybridization, and the hybridization for any tetrahedral is sp3. All right, and so that's all we needed to know. That's all we answered, and so we move on. Hopefully this helped you. Thank you for watching. Please like and subscribe.